Intel was once the most dominant technology company on Earth, not just in chips, in the entire technology industry. For 3 decades, from the late 1970s through the 2000s, the name Intel was synonymous with computing itself. Every personal computer ran an Intel processor. Every data center bought Intel server chips. Every laptop, every workstation, every government computer on the planet was built around Intel's architecture. The company's market cap at its peak approached $500 billion. Its processors defined what computing was and what it could become. That world is gone. And it did not end the way most people expected. The story most technology analysts were telling about Intel's decline focused on AMD, the scrappy underdog that, starting around 2019, built a better chip and started taking Intel's customers one by one. Then came NVIDIA, which turned the entire data center industry toward GPU-based AI compute and left Intel's server roadmap looking like a relic from another era. Those stories are real, but they are not the full story. The part of the story that almost nobody in the West is talking about is happening in Beijing, in Shanghai, and in the server rooms of hundreds of Chinese government agencies, where, as of December 2024, Intel processors are no longer welcome. Not preferred less, not gradually being replaced. Officially banned. China's Ministry of Finance and Ministry of Industry and Information Technology issued formal procurement guidelines in December 2024 prohibiting Intel and AMD processors in government computers and servers. In their place, 18 approved domestic processors primarily from 2 companies called Loongson and Phytium are now the only options for the world's largest government computing procurement program. And state-owned enterprises, which employ hundreds of millions of workers and run critical infrastructure across China, were also instructed to begin the same transition. With a completion target of 2027, this is not a future threat to Intel. It is a present one. And understanding how it happened and what comes next requires going back to a company most people outside China have never heard of, and a processor that the West dismissed as irrelevant for 20 years. Loongson Technology was founded in 2001, not as a startup in a garage, but as a research project under the Chinese Academy of Sciences, China's most prestigious state-backed research institution. The project had a specific mandate: build a Chinese processor that does not depend on American intellectual property or American manufacturing. Not a clone, not a workaround, a genuinely sovereign chip. The technical challenge that mandate created was enormous. The global processor industry runs on a handful of dominant instruction set architectures, the fundamental languages that software uses to communicate with hardware. x86, which Intel and AMD developed and own, controls the vast majority of desktop and server computing. ARM controls mobile. Everything else is a rounding error. To build a Chinese processor that doesn't depend on American IP meant building a new instruction set from scratch and then convincing an entire software ecosystem to support it. Loongson spent its first decade simply surviving that challenge. Its early chips ran on a MIPS-derived architecture, MIPS being a reduced instruction set architecture originally developed at Stanford University in the early 1980s. Loongson had licensed MIPS rights, but the dependency on a foreign architecture created exactly the kind of vulnerability the program was designed to avoid. In 2020, Loongson made the decision that would define its next decade. The company developed LoongArch, a completely proprietary instruction set architecture. Not MIPS, not RISC-V, not anything with a Western license attached to it. A fully Chinese CPU language owned entirely by Loongson, developed by engineers in Beijing who answer to no foreign licensor. The engineering challenge of building a new instruction set from scratch is difficult to overstate. It's not just writing the chip. It's building the compilers that translate code into that chip's language. It's getting operating systems to run on it. Linux support for LoongArch was only accepted into the main Linux kernel in 2022. It's convincing the software developers who write the applications that run on government computers to port their code. Every layer of the stack has to be rebuilt. But here is what Loongson had that no American startup building a competitive chip could count on: guaranteed demand. When the Chinese government decides that its procurement program will only accept Loongson chips, it doesn't matter whether the chip is as fast as Intel's latest. It matters that it works. And through China's XinChuang program, a national IT substitution initiative specifically designed to replace foreign hardware and software in government and critical infrastructure, Loongson had exactly that guarantee. XinChuang, which translates roughly as innovation in Mandarin, began building serious momentum around 2019, the same year the United States began its most aggressive technology export controls targeting China. The export controls intended to slow China down. What they actually did was remove the last hesitation from Chinese procurement officials who had been debating whether domestic alternatives were good enough. Once the question became, can we actually keep buying Intel chips indefinitely? The answer was obvious. Maybe not. And maybe not is not a foundation you build critical government infrastructure on. The procurement shift accelerated, and Longson's engineering team, now working with the urgency of a national strategic program rather than the ordinary competitive pressures of a technology company, began producing results that closed the gap faster than anyone outside China had expected. In November 2023, Loongson launched the 3A6000, its most advanced desktop processor to date, and the first chip to run on the company's fully proprietary LoongArch architecture at a competitive performance level. The benchmark numbers were remarkable not because they were extraordinary by global standards, but because of how far they had come from where Loongson started. The 3A6000 is a 4-core processor running at up to 2.5 GHz on a 14-nanometer manufacturing process. In integer performance, the kind of calculation that dominates office computing, document processing, web browsing, and database operations, independent benchmarks showed the chip achieving instructions per clock performance comparable to Intel's Raptor Lake architecture and AMD's Zen 4. The current flagship consumer architectures from both companies. The benchmark used for this comparison, SPECCPU 2017, is an industry-standard test measuring raw processor capability independent of clock speed. At the same clock speed, Longson's core design is competitive with the best designs Intel and AMD have produced. The caveat is real and important: at the same clock speed. Intel's and AMD's processors run significantly faster than 2.5 GHz. In practice, current Intel chips boost to 5 GHz and beyond. Clock speed multiplied by IPC determines real-world performance. And on that combined metric, Longson's 3A6000 performs roughly comparably to Intel processors released around 2020. That's a real gap. Intel 2020 performance in 2024 is not cutting edge. But here is what the benchmark number misses, and it's the most important thing about this story. For the tasks that government computers actually do, Intel 2020 performance is entirely sufficient. Processing tax records, managing citizen databases, running government office software, operating the infrastructure of a country's administrative apparatus. None of those tasks require the latest generation of Intel silicon. They require reliable, stable, well-supported processors that run the software the government needs and don't come with the geopolitical risk that Intel chips now carry. By May 2026, Loongson had shipped over 1 million units of the 3A6000. 1 million. For context, this is a chip that didn't exist 2.5 years ago, built on an instruction set that didn't exist 5 years ago, for a market that was entirely dominated by American companies a decade ago. The next generation is already in development. Longson's 3B6600, expected to begin shipping in the second half of 2026, targets performance parity with Intel's 12th generation Alder Lake processors released in 2021. Each generation is closing the gap by roughly one Intel product cycle. The 3C6000 server processor series, aimed at the data center market, targets performance comparable to Intel Xeon chips from 2021, with configuration scaling to 128 cores. State-owned enterprises in China's energy sector, including China Energy Investment Corporation, one of the world's largest power companies, have already selected Loongson processors for their office computing procurement in consecutive years. There is one more data point worth sitting with before we get to Intel's situation. In 2021, before the formal procurement ban, before the XinChuang program had fully accelerated, Loongson was already supplying CPUs for most desktop computers procured by the Chinese government and 80% of China's government servers. That figure comes from reporting at the time, and it reflects a quiet reality that the formal December 2024 ban only made official. China's government had already been moving toward domestic chips for years. The 2024 guidelines did not create the transition. They mandated its completion. Now put Longson's trajectory alongside Intel's. Because while China has been building up, Intel has been falling apart in ways that were almost unimaginable a decade ago. In 2024, Intel's stock lost 60% of its value. Not 60% from its peak, 60% in a single year. The worst annual performance in the company's history. Intel's share price had previously collapsed in a single day by 26% in August 2024 after a catastrophic earnings report, its largest single-day loss since the dot-com bust. The company reported a net loss of $1.6 billion in the second quarter of 2024 on revenue of $12.8 billion revenue that was 1% lower than the year before, in a year when every competitor was growing. Intel cut 15,000 jobs in 2024. 15,000. Then cut more in 2025. Then cut more again. By the time new CEO Lip Butan, who took over in March 2025, finished restructuring the workforce, Intel's global headcount had fallen to approximately 75,000 employees, down from nearly 100,000 just 2 years earlier. 2 decades of accumulated institutional knowledge laid off. The Germany fab was canceled. The Poland fab was canceled. The Ohio Mega Fab, a $20 billion project anchoring America's semiconductor independence strategy, was delayed indefinitely. Intel's Foundry division, which the company bet its entire future on the idea that Intel could compete with TSMC as a contract manufacturer for other companies' chips, posted a $3 billion operating loss in a single quarter in mid-2025. Not for the year, for a quarter. The business lost $7 billion in 2023 alone. Customers who might have used Intel's Foundry service looked at those numbers and chose TSMC instead.
Remarkably,
the strategy that was supposed to save Intel was consuming capital faster than the chip business could generate it. Tan, who brought genuine credibility from decades of leading CADEN/CE design systems, was direct in his assessment of Intel's position. The company, he acknowledged, was no longer in the top 10 semiconductor firms globally by revenue. It had missed the AI wave that NVIDIA rode to $1 trillion market cap. Its chance to lead in AI computing, he said, may have already passed. That sentence "may have already passed" from the CEO of Intel is a sentence that would have been incomprehensible 10 years ago. Meanwhile, China's government ban on Intel and procurement was not just a policy document. It was the formal beginning of an extraction, the systematic removal of Intel's installed base from the world's largest single-country government computing market. Intel had, for years, sold processors to Chinese government agencies, Chinese universities, Chinese state enterprises. That market is now closed. Permanently, even if U.S.-China relations improve tomorrow, Chinese procurement guidelines now have an approved domestic processor list. Intel is not on it. There is no political path back that doesn't require China's government to publicly reverse a national technology sovereignty policy. The scale of the market being lost is significant. China's central and local government bodies employ over 50 million people. The state-owned enterprise sector, with its 2027 transition target, adds hundreds of millions more computer users across industries including energy, banking, telecommunications, transport, and manufacturing. This is not a niche, it is the kind of installed base that anchors a platform. But Loongson is not alone in this race. Alongside it, a company called Phytium Technology has been building ARM-based processors for the same XinChuang market Phytium designs using licensed ARM architecture that, unlike Longson's LoongArch, runs on a globally supported instruction set with an enormous existing software base. Phytium's processors power a different segment of China's government computing, particularly in high-performance workstations and certain server applications, where ARM's software ecosystem provides advantages. The two companies are not competing with each other. They are dividing China's domestic computing market between them, with Loongson taking the desktop and general enterprise space and Phytium covering high-performance workloads. Together, the 18 processors on China's approved government procurement list represent a complete domestic alternative to the Intel and AMD offerings that used to fill those roles. There is also the question of manufacturing. Both Loongson and Phytium rely on SMIC, China's largest domestic chip foundry, for production. SMIC's 14-nanometer process is where Longson's 3A6000 is made. That same process is the one that, with multi-patterning techniques, SMIC has been pushing towards 7-nanometer class performance for AMI chips. The domestic CPU program and the domestic AI chip program are not separate stories. They share the same foundry infrastructure, the same equipment supply chain, and the same national strategic mandate. When Liangsheng's domestic lithography machines begin volume production at SMIC's fabs, the manufacturing capability that supports Longson's next-generation processors gets stronger at the same time. The software ecosystem, which is always the hardest part of any processor transition, is being built in parallel. Linux distributions with full LoongArch support are now shipping. UOS, the domestic Chinese operating system that powers most XinChuang deployments, runs natively on Loongson hardware. WPS Office, which is the dominant productivity software across Chinese government agencies, has been LoongArch native for years. The standard objection to domestic chip adoption, the software doesn't work, is becoming less true with every release cycle. There is a version of this story that is easy to dismiss. It goes like this: Loongson chips are years behind Intel's best silicon. China's government market, while large, is not the global market. Intel's real competition is in cloud data centers and consumer laptops, where Loongson has almost no presence. None of that is wrong. As a complete picture, it is also insufficient. Before that honest assessment, one more dimension of the transition is worth understanding: the financial one. From Longson's side, Loongson Technology went public on Shanghai Star Market in 2022, becoming the first CPU-focused company ever listed on that exchange. That listing gave the company access to public capital markets at a moment when demand for its chips was accelerating sharply. Revenue growth has been consistent. The company's contracts with major state-owned enterprises, China Energy Investment Corporation, has selected Loongson processors for consecutive years, provide the kind of predictable, government-backed revenue that gives a chip company the financial stability to invest in long development cycles. Loongson's chairman Hu Weiwu has been explicit about the company's mission in terms that leave no ambiguity. Build a fully sovereign Chinese processor, close the performance gap with Western chips generation by generation, and expand beyond the government market into commercial enterprise computing. The roadmap he has published is specific. The 3B6600 in 2026. The 3C6000 server series with up to 128 cores targeting Intel's Xeon performance levels, and a mobile processor line aimed at laptops and embedded systems. Each product targets the Intel generation that was released roughly 4 to 5 years prior. Each release closes that gap by roughly one Intel generation, if that pace holds. Longson's desktop performance reaches Intel's current flagship level somewhere between 2029 and 2031. The honest assessment of Longson's limitations begins with the performance gap. The 3A6000 delivers Intel 2020 performance. Intel's current flagship server processors run circles around it. For high-performance computing, the kind that runs AI training, scientific simulation, complex financial modeling, Loongson is not a competitor today, and the gap in that segment is measured in years. The manufacturing constraint is equally real. Longson's 3A6000 is built on a 14 to 12 nanometer process. Intel's current chips use Intel 4, equivalent to roughly 4 nanometers. That manufacturing gap limits clock speeds, power efficiency, and transistor density in ways that create a fundamental ceiling on performance until China's domestic semiconductor manufacturing catches up, which, based on the lithography machine situation, is still several years away at best. The software ecosystem, while improving, still has gaps. Enterprise software from global vendors doesn't run natively on LoongArch without translation layers that add overhead. Developers who learn to write for x86 have to relearn workflows for a new architecture. These are real friction costs. And Longson's global market presence is essentially zero. Every Loongson chip currently shipped goes to China's domestic market. The idea of Loongson competing with Intel and American data centers, European enterprise computing, or Southeast Asian consumer laptops is, for the foreseeable future, a thought experiment rather than a business plan. But here is where the larger story becomes important. Because the Loongson versus Intel framing treats this as a conventional chip market competition, and it is not. What is actually happening is something different in kind. When the Chinese government bans Intel from government procurement, it is not saying we found a chip that is better than Intel's. It is saying we have decided that technological sovereignty is more important than performance optimization, and we will accept the performance trade-off to get there. That is a political decision masquerading as a procurement decision. And political decisions that serve genuine strategic interests, as this one does for China, tend to be durable in ways that market decisions are not. The XinChuang program is not waiting for Loongson to match Intel. It is creating the installed base that makes Longson's trajectory commercially sustainable regardless of the performance gap, so that by the time Longson's chips are genuinely competitive, which the current development pace suggests, is roughly 2028 to 2030, for most enterprise workloads there will already be millions of Loongson machines in Chinese government and enterprise environments, running LoongArch native software, supported by a domestic supply chain, with no Intel dependencies anywhere in the stack. That is a different and more durable competitive advantage than winning a benchmark. It is building an ecosystem that Intel cannot enter. Understand what that means for Intel's long-term revenue base. China, before the procurement ban, represented roughly 27% of Intel's global annual revenue, approximately $14 billion per year at peak. That revenue is not going to zero immediately. There are existing machines that need servicing. There are transitions that take years. But the direction is clear, and it is one way. Each year that passes, the installed base of Intel chips in Chinese government computing shrinks, and the installed base of Loongson chips grows. $14 billion of annual revenue does not disappear without consequence. Especially when Intel is already posting billions of dollars in quarterly losses from its foundry division and has canceled major capital expenditure programs across Europe and the United States. The combination of losing China's government procurement revenue while simultaneously burning cash on a foundry strategy that isn't generating customers creates the kind of financial pressure that changes what a company is capable of investing in for its own future competitiveness. XinChuang of NVIDIA described China's $50 billion AI market as an opportunity NVIDIA can no longer access due to export controls. For Intel, the story is different, but the direction is the same. A major portion of a major market is systematically closing. The mechanism is not export controls blocking Intel from selling. It is domestic policy redirecting China's procurement toward Loongson. The effect on Intel's revenue line is similar either way. The trajectory of all of this points somewhere specific. Not toward Loongson replacing Intel globally, that is not the near-term story, but toward an increasingly bifurcated world where Chinese computing infrastructure runs on Chinese chips made by Chinese companies. And the global market that Intel operates in has permanently lost its largest single national customer base. Intel's engineers in Santa Clara are not standing still. The Intel 18A process node, if it performs as the company hopes, would represent a genuine return to manufacturing leadership. The company's partnership with NVIDIA for advanced packaging is real. New CEO Lip-Bu Tan has a track record of operational discipline that the previous leadership lacked. The path to Intel's recovery exists. But it runs through a world where China, once 27% of Intel's annual revenue, is no longer a customer, and where the domestic processors that replaced it are shipping in the millions, running on a completely independent architecture. Supported by a government with both the resources and the political will to see the transition through to completion. That is the Intel story nobody in the West is telling. And the reason it matters is that it is already happening, in real time, one government office at a time. If you have been following Forgefront's coverage of China's semiconductor programs from the AI chip race to the lithography machine developments, you already understand that what we are watching is not a series of isolated stories. It is a single story about a country that decided, sometime around 2019, that it was going to build every piece of its technology infrastructure from scratch rather than remain dependent on a Western supply chain that had shown it was willing to be weaponized. The H100 chips that NVIDIA can no longer sell to China. The ASML lithography machines that the Netherlands won't ship. The Intel and AMD processors are now formally banned from government procurement. Each restriction, intended to slow China down, has become the justification for another leg of a domestic technology program that, piece by piece, is constructing a parallel computing world. That world is not finished. It is not yet globally competitive at the frontier. But it is real. It is accelerating. And the companies whose revenue models assumed permanent access to China's markets are beginning to discover what it means when that assumption turns out to have been wrong. The question I want to put to this community is straightforward. Do you think Loongson and China's domestic chip program will reach genuine global competitiveness within this decade? Or will the manufacturing gap, the software ecosystem challenge, and the sheer accumulated advantage of Intel's installed base in the rest of the world mean that this remains a China-only story for the foreseeable future? Drop your answer below. And subscribe if you want to follow the next chapter, because the next generation of Loongson server processors is already in tape out. And what it benchmarks will tell us a lot about how fast this story is actually moving.